I'm Chris Bryant, CCIE number 12933, and welcome to this combination CCNA, CCENT, and Network Plus 2009 video training session on dynamic routing protocols. I want to tell you immediately that no matter what your experience level or your comfort level is with dynamic routing protocols, even if you have no experience and you have no comfort level, we've all been there. I know exactly what that was like. There is something in this video for you, so hang in there. We're going to be hitting the high points of each one of these protocols, and I have plenty of other videos on YouTube and the main website at thebryantadvantage.com/tutorials that will cover some of these protocols for you in more depth, and also of course at networkpluscertification.com, our Network Plus 2009 only certification website. The dynamic routing protocols we're focusing on are the Routing Information Protocol, RIP, EIGRP, the Enhanced Interior Gateway Routing Protocol, OSPF, Open Shortest Path First, which sounds like a great idea, and IS to IS, the Intermediate System to Intermediate System. For you CCNA candidates, you're not going to see IS to IS on your CCNA exam. That's going to be in your CCNP study, certainly, when you're working on the BSCI exam. But I want everyone watching the video to know that both OSPF and IS to IS are what we call link state protocols. Before we discuss what the heck that means, let's talk about one kind of route that routers already know about, and that is a directly connected route. Let's take a look at what I mean by that, and I'll magnify that just a bit. You can see here this particular router, and you should be familiar with this symbol with the 3D circles and the arrows on top. That is a router in network documentation and in any of your exams, so you need to know that without being told that this is a router. You can see that I've configured the Ethernet 0 and Ethernet 1 interfaces with IP addresses from the major network numbers 10.0.0.0 and 20.0.0.0. Well, the router does not need to be told about the existence of those networks because it is directly connected to them. Obviously, we're going to need a lot more routes than that for our host to be able to get, say, to internet-based websites, hosts, and that kind of thing. But again, the directly connected routes are already going to be known by the router. And for those of you working on Cisco exams, you should know that in your IP routing table, the letter C is going to indicate a directly connected route. We also have static routes, and I'm definitely not bashing static routes here or saying they're bad, and certainly you CCNA candidates need to go out and watch my other videos. I've got plenty of those on static routing. And the reason is that static routing can become very important to you in real-world networking as well as studying for the exams, but they do have some drawbacks. They don't dynamically adapt to a network change, which of course is why we call it static. We write it and that's it. And if the network changes, network goes down, a segment goes up, and we need to get to it, we've got to go back and we've got to change the routing statements ourselves. They're not particularly scalable, and for those of you who may be running into that term for the first time, glad I could be the first one to tell you this. You'll be hearing about 2 million other times during your networking studies, but it is an important term. By scalable, we mean we can grow. And if we're using a scalable solution, that means it's a solution that we can continue to use effectively, and that includes time efficiently and effectively as the network grows. With static routing, as your network grows, it can be difficult to just keep adding static routes and make sure everybody can still get to everything they need to get to. And again, they require that manual updating to reflect any changes, and again, that's you and I as the network admins. That's more work for us, and frankly, we got enough to do. So while static routes can come in handy, it's not something we want to build our network around. We probably want to use a dynamic routing protocol. And you create these on Cisco routers with the IP route command. Let's talk about the Routing Information Protocol, RIP. We have two versions, version 1 and version 2. Version 2 is generally preferred when you're using one or the other in real-world networks. There are several reasons why. The main ones being that RIP version 2 supports variable length subnet masking, and also that RIP version 2 multicasts updates rather than broadcast them. And I've seen some Net Plus 2009 material out there, documentation out there that talks about RIP version 2 being a broadcast protocol, and it is not as a multicast. And as you'll see, that's a very important line. One problem with both is that they're both sending out full routing tables every 30 seconds, and that is a lot of overhead, because we've got to keep in mind that everything we do on a router or with a switch has a cost. And I mean a cost, there's a little bit of CPU usage, a little bit of a memory hit, a little bit of time that we're losing maybe doing something we don't need to be doing. And full routing tables every 30 seconds is really unnecessary, especially if you have a stable network, which hopefully we do. You definitely don't need a full routing table to go out every 30 seconds, because not only does your sending router have to pack those routes in an update packet and send it out, then the receiving routers still have to unpack it and say, oh, nothing changed since half a minute ago. But that's a little bit of power and a little bit of time that it's got to use doing something that is really unnecessary. That's why we tend to gravitate toward protocols like OSPF. This is a link state protocol, as is IS to IS, and OSPF does not advertise a routing table per se like RIP does. What it actually does, it advertises the state of its links. It can understand the speed of a link and make much more informed routing decisions than RIP can. Let me show you what I mean by that. In this particular network, you can see that we've got two ways to get from router 1 to router 2. We can go through router 4, which involves two 512K links, or we can go from router 1 through router 3, which involves two T1 links. The issue is that while OSPF can be made to easily understand these speeds, and will understand several speeds by default depending on what kind of interface it is, RIP is going to see these paths as being equal, because all RIP understands is hop count, which is not a terribly scientific way of deciding which path is best. Literally, RIP would say 1 hop, 2 hops, 1 hop, 2 hop. I know it sounds like Dr. Zeus, but it's not. It's RIP. And RIP would decide that these paths are equal. And that's not something we want. Obviously, one path is far superior to the other. OSPF would realize that by default, but RIP would not. Now, EIGRP, this is called the hybrid protocol because it has some behaviors of distance vector protocols, like RIP, and some behaviors of link state protocols, such as OSPF and IS to IS. We can't go into all of these right now just looking at the high points, but that's why we call it a hybrid. And there may be one other phrase, especially for you Network Plus 2009 candidates, that you may not have run into yet. Cisco proprietary. You're going to run into that a lot in your CCNA studies and beyond, and it simply means that only Cisco devices can run it. So if we had a non-Cisco router involved in a WAN, we most likely would be using OSPF, because we probably don't want to use RIP, and we definitely cannot use EIGRP. So that concludes our look at the high points here of those particular protocols for you Network Plus 2009 candidates. You can always visit CompTIA's website for much more information on that certification, and also I invite you out to my website. I'm putting new tutorials and videos on every day at networkpluscertification.com. And of course, those of you working on your CCNA and Network Plus, you can visit my main website, thebryantadvantage.com, and go to tutorials page for over 300 free videos, practice exams, and a lot more coming. My YouTube Cisco certification channel will also be CompTIA certification channel after the next video. And I invite you out to the blog at thebryantadvantage.blogspot.com. Daily free practice exam questions, upcoming webinars for Network Plus 2009 CCNA, and all kinds of other great stuff. So thanks for taking a few minutes out of your day to watch this video. I'm Chris Bryant, CCIE number 12933.